Hi guys, and welcome to the series of common interview questions in software engineering. In this lecture we will discuss the HashMap, how it works, and after this video you'll be able to answer any question regarding HashMaps in your job interview. So before we start, let's define first what a HashMap is. So a HashMap is basically a key value pair. This means we have a key, and for each key we have a value. This is a pair. And how do we create it in Java? We create it in Java with this term basically, right? So we define the type of the key, which is string, and then we define the type of the value, which is a string in this case as well. Of course, you can choose here also, for example, integer. And then we call it with a new operator, new hash map. And this is how we create our map. So the next question is what happens after that? So once we call this hash map with a new operator, the JVM will take this object and create it inside of our heap. As we know, the heap is a location in our memory on your physical computer, and every Java object is created inside of this heap. So when we create a new hash map, the JVM will create an object with 16 buckets. I try to visualize it here, right? We have here 16 buckets, 1, 2, 3, and then 15, 16, and of course all the numbers in between. So this is our hash map. And when we add a value, it will be added inside of one of those buckets. One important thing to mention here is that once the bucket gets to 75% full, it will create the other amount of 16 buckets as well. So then we would have 32 buckets. And now it's becoming interesting because inside of just keeping these buckets, we have one separate data structure within these buckets, and this is called a linked list. If you don't know what a linked list is, it's basically some other data structure. You have to Google it, or I can make another video of it because we will not cover it in this video. But let's zoom in and just double check here. So we have a bucket, and inside of this bucket we have a linked list. You may ask yourself now, hey, why do we have a linked list here? Well, the problem is hash collision, and I will explain it later in the video. So now we have our 16 buckets, but the question is, how do we add a value to one of our 16 buckets in our hash map? So before we explain this, we need to know one thing. Every Java object has basically a hashcode method. So no matter whether it's a string object or if you create your own custom object, every Java object has a hashcode method, and you can even override it. So this is a very important part to understand. So if we want to add something to our hash map, we simply use the put method. So in this case, we added a value Chicago with the key first. So now, how are we using the hash code? So basically, we take the key, we use the hash code. The hash code in this example is 1159. And out of the hash code, we are basically calculating where to put it in our HashMap bucket. And we use something like a modulo operator here. However, since we are always on the power of 2, we can also use the bitwise operator here. So we take our hash and then we use the bitwise operator with 16 minus 1, because we have the length of our buckets, which is 16. We have 16 buckets, but we start, of course, counting with 0. This is why we have the minus 1. And the result is 7. So this means if we have a key which name is first and a hash code of 1159, we will put it in the 7th bucket, as you can see here, basically. So this will go to this bucket. And as I told you before, we have a linked list inside of it. So it's the first value of the linked list. One question is maybe, what happens if we have another value, let's say, for example, 7,000, and the 7,000 also has the hash code of 1159, which in return means that we will put it in the 7th bucket. Well, then, and this is why we have hash collision and the linked list, then we have to put it in the second stage, so in the second node. So if we have another value, which will also come in the 7th bucket, we will put it here always in the end. Okay, so let's visualize this concept of hash collision again to make it really clear what's happening here. So this is our situation where we have been before, right? We have our value Chicago, which with our key first, and we know the hash code is 1159, and in the end we put it in the 7th bucket, right? So what happens if we have another value, which is basically Berlin, and Berlin has the key Apple? We find out that Apple has the same hash code. This can happen. And the hash code is 1159. Of course, this whole calculation is the same. So this goes in the same bucket, right? And this is called a hash collision. This means that we have basically two values going in the same bucket. Now we know already that we have here a linked list, but just imagine we wouldn't have a linked list here, right? We would have just one place to add one value. This would be a problem because then we would have basically two hash codes which are the same, but they have different keys. And this would basically mean that we will lose one value. So how is the JVM doing it? The JVM is basically testing, okay, this new hash code. Is it the same value? So is first equal to first, or is it Apple? And we see first is of course different to Apple, and then it will add it in the second place of the linked list. Let me zoom in here so we see it better. So here, we have first already as the first node, and now comes the second value, and the JVM will check, okay, is this second value equal to first or is it something different? As we have Apple, it will see it is something different, and this means it will add it at the second node. And with all of this knowledge, we basically know why the HashMap is used, right? We use the HashMap because it's very fast at lookups. In big O notation, we say it's a big O notation of 1. So it's very, very fast at lookups. And we basically know how it's looking after a value. So you can use a get method. The get method is basically taking the hash, and then it knows exactly in which bucket it has to search. So it doesn't have to search through all of this bucket, but it can immediately say, hey, it's at the 7th position. And as you may have figured out, the linked list inside of it is a little blocker, because in the linked list, we have then to go linearly, right? We have to go from the first to the second to the third value, but it's still way faster than having a simple array.